negative 4 both divide by 2, right? X squared and x both divide by x. And now I'm skipping you. Oh, you got a full note. Desiree, do you have a full note? Okay, Desiree. 3x and negative 6, what are both those numbers divided by? Yeah? Very good. They both divide by 3, so 3 minus 6 minus 2. Okay, can I get everyone to close your eyes for a sec? Who caught that? Raise your hand. Who came close and made a small mistake? Okay. Who's nowhere in the right ballpark? Okay. Okay, so let's finish this up here, please. Final step, Karina, is going to be what? Final step here is going to be what?
Oh, I mean, okay. It's going to be, give me a second.
Yeah, no problem.
It's
okay. I'll come back to it. Somebody help here for right now. No, you want to try?
Is it 2x plus 3, like the bracket?
Yeah. Great. This is also acceptable, so if you wrote that down wrong, that's wrong. If you wrote that down backwards, either way works. Either one of those is correct, and that's fine. Okay. Now, again, we'll do a few of these to make sure we feel good, because as I keep saying, factoring is tremendously important. If you're not 100% there yet, do not worry. Okay, we still have probably 2 weeks left in this unit, okay? So you have 2 weeks to be a master. Actually, you know what I mean, plus March break, okay? So 2 weeks plus March break to be a master. Okay, I'm going to move on to my graphing stuff, and then we'll get back to today's lesson, hopefully, okay? So here we go. Our graphing question here, oh boy, this is a long warm-up. It says here, graph y equals negative 2 bracket x minus 3x plus 2 using y-intercept, x-intercept, axisymmetry. If you take a look at what we just did, this is now in factored form, right? So this is also in factored form, all right? So what we're doing is we're leaving it into being able to graph an x squared and the x squared term. Okay, let's start with y-intercept, please. Megan, I'm going to pick on you. How do you get the y-intercept? No, close though. You said, what would you say? Set x equals 0. Now, it can't just be negative 2. It would be if everything was FOILed out. It would just be the last number, right? But it's got to be here. So it's, we're going to say here, y equals negative 2, bracket, 0 plus 3, and then 0 minus 2. All right, Calvin, what is 0 plus 3? What is 0 minus 2? Good. You're not done yet. What is negative 2 times 3, Calvin? Good. And what's negative 6 times negative 2? Good. Now, if you're saying to yourself, uh-oh, I'm sitting at the front and I don't know how to times that in my head, please get comfortable with those numbers, okay? Times into 12 should not be something that's scary to you. I'm sorry for being mean, okay? I can't help it. I'm a mean human being. I'm a math teacher. Bailey, what point will that be on my graph? What comma what, please? Very good. Okay. Feeling somewhat okay with that? Yes? Most people? Okay. If you haven't done this since Friday, that's fine. Okay, right? But hopefully this should be somewhere in your long-term memory at the back, somewhere, hopefully. Okay. All right. Next up, it's going to be Hannah. Hannah, let's do our x-intercepts next. How do we find the x-intercept? Great. All right, Hannah, you don't get off that easy today. How does that help us solve our x-intercepts? What do we do?
You take out x plus 3 equals 0.
Very good.
And x minus 2 equals 0.
Good. And if you weren't here last week when we did this, what we're saying is you have to have numbers that multiply to get 0. So the only way to time something by 0, Luke, is to make sure it's equal to 0. And pick on Noah. Noah, what is 8.9328492 billion times 0? Good. Okay, right? So the point is, the only way to get 0 is that one of those two things has to be 0. Can negative 2 ever equal 0? I don't think it can. Negative 2 is always negative 2, right? So it can't do anything. So I tell you one of those other brackets. Luke, I'd like you to use your great algebra skills. If x plus 3 is equal to 0, what does x equal? X equals 2. Great. On the right-hand side, if let me ask the question, please, before you answer it. Luke, since you know everything about, oh, sorry, yeah.
Question. So, Angela was like positive first,
Yeah.
now it's negative, then you're bringing it across like this.
Yes, yes. So the other way to think, okay, you guys, hold on a sec, please. Hold 1 sec. And talk, please. Yeah, you can either think it was bring across the equal sign like algebra, or you can just think, well, negative 3 plus 3 is 0. Right, either way. All right. Emily, if I wanted to graph these points, they're going to be what, comma, what? Yeah, so when it's negative 3 here, what's the y going to be? X is negative 3, what's y going to be? It's going to be 0, right? Because if you think that's what we're starting point, that's so we're that's from negative 3 comma 0, and then 2 comma 0. Right? Before we do our axis symmetry, I'm going to graph this. Okay, you only graph here for today's lesson, assuming we get to a lesson today, which is sort of doubtful. Okay, but we're not done the question. I do the axis symmetry, but I'm going to graph these 2 points first. Okay. Probably I'm doing my vertex up to about 15, I guess. Okay. So what I'm going to do here is I'm going to, if you don't have graph paper handy, please gently ask your neighbor for some, and they will owe you forever. We're never done graphing. Sorry, whoever said that, shame on you. We're never done graphing, ever. Ever. No. In this class, we'll be doing graphing all through our quadratics unit. Okay, so once we get to quadratics. All right, so I'm going to borrow your paper again here if you don't mind. Just as a reminder, I know I keep doing this. This is about big enough for a graph like this on one of those 4 corners, okay? If you want to use front and back, that's fine. So let's do this here. Now, again, I'm going to leave lots of room left and right because I know how far I only need to get to left and right. If I said, what was on one? I said 12, I'll probably go to 15. I went a little bit higher, but probably 15 should be enough. Please remember when you're doing your graph, it's okay to have different scales. As long as you're consistent left and right, consistent up and down, that's okay. So if you take a look north-south, my y values were only like very, very small. Left and right, I wanted to use the entire page. So I had like big giant, like probably every 2 squares counted as one for me on this. Okay. I'm going to plot my points as you're going here. So 0 and 12 comes first, which is up here. Negative 3 and 0 is over here. And 2 and 0 is over there. Okay, so this looks like to me it's going to be a downward shaping parabola, right? Before I ramble on too quickly, does that sort of make sense what's happened there so far? Luke's nodding his head, other than Luke though. Yes, we're good? Okay. Jasmine, I see you scribbling your graphs, so I'm not going to need you yet. But I'd like you to think, if you can, how we find our axis symmetry. So we'll do that next. Very good. So what I'm going to do for my axis symmetry, it's just going to be what those two numbers are, okay? So I'm going to say x equals negative 3 plus 2 over 2, which is negative 1/2. Now, okay, let me go through here to say x equals negative 1/2. You may also use the finger method. The finger method doesn't work well, okay, because in case there's like decimals and stuff, okay? So what I'm going to do is I'm going to draw a little dotted line, right, like this. Oh, goodness. It's supposed to be straight, right? And right here, x equals negative 1/2 axis. What does the axis symmetry give me? What does the axis of symmetry give me? Anna, go.
Is it like the line where you're...
It is the line where the vertex is very good. What else is it? One other thing. Yeah, it's like the middle of your graph. So if you're doing this on paper, which you are, you could actually fold your graph up in half like that. One thing I'm going to force you to do today, okay, and today only, is I'm going to do reflections, because today we're actually going to deal with reflections. If I have a point here at 0 and 12, what will the corresponding point be on the left-hand side of the graph? I'll open this up to anybody here. Aiden, go. What was that? Negative 112. How'd you get that? Right. Okay. So what Aiden did correctly was he thought, well, if you go over half a unit this way and you get to 12, that also means you're going to go over half a unit this way and get to 12. Okay, it's going to be the same thing balancing left and right, and that works the same thing here. If you go over 2.5 units this way, you get to -3. If I go over 2.5 units this way, I get to 2. Right? It's going to be the same balance all the way through. All right, who are we up to now? Jessica, how do I get my vertex then? Great. I'm not going to be kind today. Yeah, I'm going to be kind today. Okay, so I'm going to do this very, very quickly here. So if you turn into y equals -2 times -2.5, sorry, times +2.5 times -2.5, that should be 12.5. Okay. Therefore, my vertex is -1/2 and 12.5. If you did that as far as fractions, wonderful, good for you. I chose not to though, and there's the decimals there. Okay, so if you did it in terms of fractions, wonderful. Okay. All right, so I'm going to draw my parabola. It's going to look something like this. I'm going to put arrows on all two sides. Please remember, parabola is supposed to be a curve. All right, so if you use a ruler to don't. Okay, so it's not supposed to be. No question.
Axis, why do you, like, how do you divide by 2?
Well, because it's like the middle. Like it's like the average of the 2 points. So if you're doing like your 2 tests were 79 and 85, to get the average of the 2 tests, you like add them together and divide by 2 because you get like the middle. So the middle of anything is just like the average. That's the yes.
When you got 12.5, you just go -2 times 2.5 and then take that and then multiply by
Yes. Okay, and I'll put my title on here, which is going to be y equals -2, x plus 3, x minus 2. Okay, please put a star and a heart beside this question, okay, because this is guaranteed to be on your test. I love graphs, and I know you guys hate them, but that's why I'm a math teacher and you guys are math students. Okay? So that's a mean joke. I like graphs. All right, I'm going to stop on the paper, and then we'll talk about 48 as we go through it here, and then we'll hopefully do a little bit of a lesson today. I'm sorry this took so long to get water. I wanted to make sure that you understood factoring, and I also wanted to make sure that you sort of got what just happened here with these graphs. All right. So take a second. If you need a minute to finish up your graph, you may have it right now.